Alzheimer's disease, a neurodegenerative condition characterized by memory loss, cognitive decline, and profound changes in behavior, affects millions worldwide. At its core, Alzheimer's is influenced by genetics with variations in several genes altering risk. Key among these are the APOE E4 allele, associated with late-onset Alzheimer's, and mutations in APP, PSNE1, and PSNE2. Almost certainly leading to early onset Alzheimer's. These genetic insights open the door to understanding and potentially managing the disease's impact.
The 23andMe and our SNP chip test both aim to identify genetic predispositions to Alzheimer's. While 23andMe focuses primarily on the APOE E4 allele and its impact on APOE production and function, our test expands beyond the solitary indicator to include approximately 1,000 genetic variations that are expressed in the brain and are integral to neural health. By exploring the complex interplay of variations that shape protein functions and gene expressions, we answer the crucial question of whether these variations can alter cognitive traits as they are intricately connected to neural pathways disrupted in Alzheimer's disease. While 23andMe provides valuable insights, it does not fully explore all known alleles or the breadth of genes implicated in Alzheimer's. Our comprehensive approach is designed to capture a complete genetic landscape, delivering a more in-depth and actionable genetic profile that's essential for understanding the myriad ways this disease can manifest. Our advanced SNP chip evaluates around 1,000 genetic variations with utmost care, providing an extensive understanding of the chances of developing Alzheimer's. Our test focuses on the APOE E4, E3, and E2 alleles, which are known for significantly impacting brain health by altering the proteins responsible for lipid transportation and plaque clearance in neuronal cells. We also analyze genes like ABCA7, CLU, CR1, PICALM, PLD3, TREM2, and SORL1, which are crucial in how the brain handles cholesterol and inflammation while aligning structural protein changes with neural function. Our test can identify deterministic mutations in APP, PSEN1, and PSEN2, genes expressed in brain cells responsible for processing amyloid precursors and synaptic function, making them highly predictive of Alzheimer's. Our test's depth of analysis goes beyond traditional tests, providing a path to personalized intervention and a ray of hope for those dealing with Alzheimer's.
Benefits of our test compared to 23andMe. Our S&P chip test is more useful in comparison to the 23andMe test for Alzheimer's because the 23andMe only tests for E4 variant of the APO gene, despite the fact that there are other genes that can lead to an increased risk of developing Alzheimer's. By testing other genes besides E4, we can give individuals an even more realistic and thorough determination of what is the likelihood that they will develop Alzheimer's. Research has found consistent links between additional genes that our S&P chip will test for and the development of Alzheimer's, such as the ABCA7, one of the many genes added to our test which is linked to a greater risk of developing late-onset Alzheimer's disease. Ethical considerations. Some of the financial effects of genetic testing to see if you are a carrier for Alzheimer's are that certain health insurance companies will not cover these tests because they deem them to be medically unnecessary, and testing without insurance may be too expensive for some people. Additionally, it may be upsetting for some people to discover they have genetic markers linked to the development of Alzheimer's, as there isn't much that can be done about it, and they may find themselves stressed about finances such as affording care as well as their overall lifestyle changes and lack of control that they have over the situation. On the positive side, these genetic tests allow people enough time to come to terms with the fact that they may develop this disorder in the future and allow them enough time to take advantage of their current health statuses while they can.